Thank you for choosing our program today. My major research field is coordination chemistry of cage structures, functions based on the coordination frameworks, and selective inclusion of guest molecules in aqueous media. My research theme is synthesis of molecular capsules for inorganic anions and explorations of new removal and detection methods for perchlorate ion in aqueous solutions using the molecular capsules. Combinations of metal ions and bis-imidazole type ligands provide various coordination cage compounds. For example, we have isolated these cage compounds by reactions of kappa 2 ions with these ligands. The obtained compounds have M2L4, M4L4, and M3L4 frameworks, which contain inorganic anions. We have explored the functions of the cage compounds caused by trapping the inorganic anions. Particularly, we have focused on M2L4 cage compound that traps perchlorate ion. Perchlorate ion is known as a toxic anion, which disturbs iodide uptake in thyroid gland. Much consumption of the anion is serious for newborns and children. This anion has been detected in tap water, agricultural products, milk, and fruit around the world in the last 2 decades. However, it's difficult to remove perchlorate ion from aqueous solutions because of the high solubility. Therefore, development of perchlorate removal methods and detection methods are important subjects. I would like to show the selective perchlorate anion removal by formation of the M2L4 cage compound. Addition of kappa sulfate and the bis-imidazole ligand in aqueous solutions contain various anions. Perchlorate ion is selectively removed. This is due to the formation of the water-insoluble M2L4 cage compound that traps perchlorate ion. This compound is another M2L4 cage compound, which shows high perchlorate removal activity. This compound has sulfate ion in and outside the cage. The sulfate outside the cage is quickly exchanged with perchlorate ion in aqueous media, despite the compound is insoluble in aqueous solution. As a result, it was found that perchlorate ion is effectively removed from aqueous solutions. The water-soluble M2L4 cage that traps the perchlorate is useful for detection of perchlorate ion in aqueous solutions. That is, combination of kappa 2 ion and the water-soluble ligand gives the water-soluble M2L4 cage compound in the aqueous solution. This picture shows aqueous solution of the various anion after addition of kappa sulfate and the ligand. The solution of perchlorate changed to purple, while other solutions remain pale blue. Thank you for your kind watching.